Again, today we will talk about chain rule with inverse trig, and we have the worksheet from Kuta software. Before we get started, let's understand the inverse trig functions. Now the question is, do I have to memorize all the 6 ratios of the inverse function? No, because if we know the basics, just like if I know what is the sine inverse x, derivative of sine inverse x, derivative of tangent inverse x, and secant inverse x, then I can find out for the cos inverse, cot inverse, and cosecant inverse. How? The rule is relatively simple. All the cos, that means all the functions that start with c, they are nothing but negative. Yes. So let's start with the first one. The derivative of sine inverse x is 1 over radical of 1 minus x squared, right? But derivative of cos inverse x would be just the same thing, but we have a negative sign right there. As simple as that. So for tangent inverse x, the derivative is 1 over 1 plus x squared. But when I talk about the derivative of cot inverse x, the same thing, but with a negative sign. And the same thing will go with cosecant inverse x. Cosecant inverse x is the negative of derivative of secant inverse x. Now, that being said, now the question is how we got these derivatives, right? Let's start with sine inverse x. I will show you how we derived sine inverse x, derivative of sine inverse x, as 1 over radical of 1 minus x squared. It is pretty simple. If you understand it, then sometimes you don't have to memorize it. It is just right there. Let's get started. So we will start with the function y is equal to arc sine x, or I can just write sine and negative 1x, both are same. So whatever works for you. Let's change it a bit to find the derivative of the whole entire function. I can rewrite this function as this. Sine y is equal to x, right? Dividing both sides by sine and multiplying both sides by sine. So this is my function. Now I can take the derivative. But we have the y and the x, and sine is with the y. So we will take the derivative implicitly. Remember, this will be the implicit derivative. Once we try that, derivative of sine is cos. So cos y, and then the derivative of y, dy dx. And the derivative of x is nothing but 1. Let's solve for dy dx. Dy dx would be 1 over cos y. Now remember, we started with y. What is y? Y is arc sine x. I can rewrite this as 1 over cos and then arc sine x. Or in a more simple way, you can say 1 over cos sine inverse x. Both of them, they are the same thing. Right? Now, from here, let's plug sine inverse x as t. If I put sine inverse x as t, I can say that sine t is nothing but x, or x over 1, isn't it? Let's make a right triangle and using the basic trig ratio, SOHCAHTOA. So if this right at the bottom, it is t, it says x over 1. What is sine? Sine is opposite over hypotenuse, right? Sine. SOHCAHTOA. So that means this is x, and the hypotenuse we are talking about is this one. Now I need to find out what is the missing side length. Let's say missing side length is a. If the missing side length is a, can I use the Pythagorean theorem, right, to find the missing side length? Let's try. So what is the Pythagorean theorem? It says a squared plus b squared is equal to c squared, right? So we have x squared plus a squared is equal to 1 squared, and I can say a squared is equal to 1 minus x squared, And finally, I will get a as radical of 1 minus x squared. Isn't it? So we have a as 1 minus x squared, and let's continue with this. So dy dx was 1 over cos sine inverse x, right? We were right there, and then we substituted sine inverse x as t, right? And then we found the answer for that one. Now, if sine inverse x was t and sine t was x over 1, what will be cos t? Cos t would be adjacent over hypotenuse. This is adjacent. Radical 1 minus x squared over 1. Right? Let's do some more magic. Cos t, because sine inverse was t right from there. I can rewrite it. 1 over 1 minus x squared. That is the derivative of sine inverse x we are looking for. So this is how you can derive it. If you understand how we got to this point, then things become relatively easier. Memorization is required in mathematics to a certain extent so that we can practice those concepts and master those. That being said, let's try a few questions from the Kuta software.